Sometime in 2025, on a test bench inside the Shanghai facility run by Semiconductor Manufacturing International, engineers powered up a deep ultraviolet immersion scanner they did not buy from the Dutch lithography maker. They built it themselves. The pressure that was supposed to keep that machine from existing is exactly what forced it into existence. Follow that single machine forward. What it prints, what it cannot yet print, and what happens to the semiconductor supply chain if the overlay number holds its volume. The machine is called the SSA-800, built by Shanghai Microelectronics Equipment and delivered to Semiconductor Manufacturing International for testing in 2025. That delivery is confirmed. What it means for every node above it in the supply chain is the chain this script traces. Export controls tightened. That is where the chain starts, and that link is confirmed. The United States restricted access to advanced semiconductor equipment for Chinese fabs, including Semiconductor Manufacturing International. The Dutch lithography maker's most capable tools, including immersion scanners at the advanced end of the deep ultraviolet product line, became inaccessible. The logic of the restriction was straightforward. Keep the most precise printing equipment out of Chinese fabs and the gap in chip manufacturing capability would hold. What followed was not stagnation. Chinese state investment accelerated into domestic lithography development at a scale that had not previously existed, channeling resources into Shanghai Microelectronics Equipment with a consistency that trade reporting has documented across several years. That redirection of capital is confirmed as a policy outcome. The exact figures involved in the investment are not independently verified in full, so the scale is better described as substantial rather than pinned to a specific number. The intent was clear from the structure of the funding: build the machine the controls were designed to prevent. That investment produced the SSA-800, a 193 nanometer light source, a deep ultraviolet immersion configuration, delivered to Semiconductor Manufacturing International in 2025 for testing. That delivery is the confirmed anchor, and it recurs at every step up this chain because it is the one fact the rest of the argument depends on. The specifications disclosed by Shanghai Microelectronics Equipment and Semiconductor Manufacturing International report a tool that prints 28 nanometer features in a single pass with an overlay specification near 1.9 nanometers. Those figures are disclosed specifications, not independently verified production results. The distinction matters, and it matters enough to say clearly: a specification describes what a tool is designed to achieve under controlled conditions. It does not describe what a tool delivers across tens of thousands of wafers under the thermal drift, vibration, and throughput pressure of a real fab floor. To understand why the overlay figure is the number the entire argument pivots on, consider what overlay actually measures. Think of it like registering two stamps on the same sheet of paper. Each stamp adds a layer of the image. If the second stamp lands even a fraction off from the first, the image blurs. At chip scale, that fraction means less than 2 nanometers, roughly the width of 10 silicon atoms laid side by side. The SSA-800's claimed 1.9 nanometer overlay means it is aiming for a target that small, repeatedly, across a silicon wafer the size of a dinner plate. That is the number on the board. Whether it hits that target on the 10,000th wafer the same way it did on the 10th is what qualification is designed to find out, and what has not yet been answered. If the overlay holds, it enables something beyond 28 nanometers in a single pass. Multipatterning uses multiple aligned exposures to print features finer than any one pass allows. At a 1.9 nanometer overlay tolerance, multi-patterning schemes could in principle push effective feature resolution toward 11 nanometers. That 11 nanometer reach is a claim from the disclosures, not a demonstrated result. It is the furthest inference in this chain, and it depends on the overlay holding not just on a calibrated test bench, but across a sustained production run at yield. Reported as a technical possibility, inferred as a practical outcome. Here is where the expectation turns over. The threat to the Dutch lithography maker's deep ultraviolet immersion franchise did not emerge from a rival with open access to the global supply chain. It emerged from a lab that was locked out of one. The controls that were meant to preserve Western leverage over chip manufacturing at the advanced nodes inadvertently concentrated investment into exactly the capability they were designed to prevent. That is not an argument about intent. It is a documented causal sequence. Restriction produced redirection, and redirection produced the SSA-800. The competitive implication is the consensus read in trade analysis. A credible domestic alternative at the deep ultraviolet immersion tier now exists for the first time, even if that alternative is at qualification stage and years from volume production. The degree of threat to the Dutch lithography maker depends on yield data and production timelines that are not yet public, so the competitive read stays in the reported to inferred range rather than the confirmed one. This is where two calls need to be made plainly. The first, the overlay specification is the single number the entire argument pivots on. Every claim downstream of it, 28 nanometers in one pass, multi-patterning toward 11 nanometers, a credible challenge to the Dutch maker's Immersion franchise, collapses if that number degrades at volume. A specification that holds on a calibrated test bench and a specification that holds across a production run of tens of thousands of wafers are different things, and right now only the first has an answer. The second call, the confirmed capability, 28 nanometers in a single pass, sits exactly at the node where China's domestic fabless design industry has the most unsatisfied demand. That alignment is not a coincidence of timing. It is the strategic logic of the whole program. Reach self-sufficiency at the node that matters most commercially before trying to close the gap at the bleeding edge. Whether the 11 nanometer multi-patterning reach ever arrives matters less in the near term than whether the 28 nanometer single pass capability ships at volume. If Shanghai microelectronics equipment reaches volume production, reported as no earlier than 2027, Chinese fabs gain a domestic source for the immersion scanners that print the bulk of the world's chips by unit volume. That 2027 figure comes from trade reporting, not from a confirmed production commitment by either Shanghai Microelectronics Equipment or Semiconductor Manufacturing International. Lithography tool qualification has a long history of slipping, and the timeline carries that caveat explicitly. Still, the strategic implication is worth stating as an inference. Tools designed to preserve Western leverage at the leading edge may have accelerated self-sufficiency at the nodes that matter most commercially, well before extreme ultraviolet becomes the relevant question for the bulk of chip production. The weak links in this chain are not hidden, and a reporter tracing it has an obligation to name them in passing rather than bury them. The overlay figure is a specification from a machine on a test bench. The 2027 mass production estimate is a reported timeline, not a confirmed schedule. The 11 nanometer multi-patterning reach is a claim that depends on the overlay holding and on a multi-patterning process that has not been publicly demonstrated at any node on this tool. And past deep ultraviolet immersion toward extreme ultraviolet, there is no confirmed domestic path before roughly 2030 by any account currently in circulation. The chain is real up to the test bench. What happens when the bench becomes a production line is the question the chain cannot yet answer. The confirmed anchor is solid. A machine exists, it has been delivered, it is under evaluation. Every link above that anchor is reported or inferred, and the most consequential link, volume production at the claimed overlay, has no public proof yet. That gap between 2025 qualification and a no earlier than 2027 mass production target is not a scheduling detail, it is the proof gap, and it is where most of the uncertainty in this chain lives. The SSA 800 does not hand China advanced chip manufacturing tomorrow. What it does is shift the question from whether they could build one, which was the open question as recently as 2024, to whether they can build 10,000 a month at yield, which is the question that starts in 2027. The export controls that made the first question urgent are now funding the research that will answer the second. That is the inversion the causal sequence reveals. The restriction did not hold the line at deep ultraviolet. It moved the line to extreme ultraviolet and bought time measured in years, not decades. The SSA 800 is the machine that makes that shift concrete enough to measure. The overlay number is on the board. Now the fab floor has to match it. Watch the next qualification report out of Semiconductor Manufacturing International. If the SSA 800 moves from a single test bench to a second tool in active production, the chain advances in a way that changes the competitive calculus for the Dutch lithography maker at the immersion tier. If it stays at one machine in evaluation through 2026, the demonstration not product gap remains open, and that is the distinction between a threat to price in and a milestone to monitor from a distance. That is the next observable marker in this chain, and it is the one number worth tracking above all the others that have been claimed so far. If you want to follow which way that number moves and what it means for every node in the supply chain above it, subscribe and turn on notifications. We follow the chain wherever the data takes it.